Hello and welcome to Taming the Beast, how a SQL DBA can keep Kerberos under control. My name is David Postlethwaite. I'm a database administrator for a large financial services company on the south coast of England. I've been a DBA for the last 10 years and I currently manage both SQL and Oracle instances. Previous to that, I was a developer using .NET, SQL, Access, FoxPro and Oracle. And way back in time, I was a Windows and a NetWare administrator. I'm an occasional contributor to the blog on gethanellis.com, and if you wish to contact me, my details are on the screen. Now, Kerberos. It's something that causes lots of problems for many SQL DBAs as well as many Windows Server administrators. I wonder how many of us have seen this error message in our time. But configuring Kerberos isn't that difficult. What should be a straightforward and simple process can lead to all sorts of issues, and trying to resolve them can sometimes be hard work. Now in this talk we're going to look at Kerberos, how it applies to SQL Server, and what we need to do to ensure it works. We're going to look at what is the purpose of Kerberos in relation to SQL Server. When do we need to use it? Do we need to worry about it at all? How do we configure it? What tools can we use? Who can configure it? Is it the DBA's job to manage and configure Kerberos? Why does it cause so many issues? Because on the face of it, setting up Kerberos for SQL Server is actually straightforward, but it's very easy to get wrong, and then sometimes very difficult to see what is wrong. And finally, how do we fix it? When it doesn't work, what can we do to try and get it working? Before I look at what Kerberos is, I want to give a scenario where Kerberos Authentication is required for SQL Server. Here is the diagram of my Windows setup. I've got an Active Directory domain called CW1, a domain controller called S002, and two SQL servers, S008 and S006. Both instances of SQL are using domain accounts to run the SQL service. I have a laptop called Clooney 10 and I'm logged in as a domain admin, and I have sysadmin permissions on all SQL instances. So let's come out of PowerPoint and let's remote onto my server called S008. So I'm on the desktop of my server S008 and I have a number of queries that I'm going to run. So let me just check that I'm on the correct database. I will truncate the table that we're going to use. There we go. Now let me do a simple bulk insert, and the file I'm going to insert is on the other SQL Server S006, and if I do that bulk insert, it naturally inserts the 1000 rows in that CSV file. Nothing complicated about that. Now let me do an ad hoc query. Again, ad hoc query, I'm going to pull some data from the person.person table on my SQL Server S006, and not surprisingly, this runs quite happily and returns the top 10 rows. I have a linked server created on my SQL instance. Here it is, S006. If I just have a look at the properties, it's a straightforward SQL Server linked server, but the important bit under security is that we are connecting using my current login. We haven't created a separate login for this. And if I run my linked server, not surprisingly, it returns the top 10 rows. The other way that we can connect to our secondary server is just by doing a direct query. So here I'm just going to query the sys databases table, and it returns a set of rows for us. Nothing difficult about any of those queries, not trying to catch you out. They're all queries that I'm sure you're all aware of. Now let's go over to my laptop, Clooney 10, and I have Management Studio running on my laptop, and we're going to run exactly the same set of queries from my laptop this time. So let's just check we are on AdventureWorks. If I hover there, I can see that I'm connected to server S008. Let me truncate my table again, And this time we are going to do exactly the same thing. I'm going to do a bulk insert from the server S006 to read it into a table on S008. And if I run this, it comes back and says access denied. Doesn't make any sense. I have access to this file. If I pick up this name and put it into my run window, I can open the file up. There's all the data in the file, 1,000 rows that we've been inserting. So how come when I'm doing it here, it will not let me do it? Doesn't make any sense. Let me try that ad hoc query again. Again, reading AdventureWorks 2012 person.person table. And again, it's failing. This time, NT Authority anonymous login. Why can't I read that table on my server S006? Here it is. I'm connected to it. If I come down and find the person.person table and do a select, I can read all the data from it. It doesn't make any sense. If I can read the data from here, why can't I read it when I'm running this query via server S008? If I run my link server, again, it's failing with NT Authority anonymous login. Similarly, if I do that direct query, I'm getting exactly the same error message. It doesn't make any sense because I can connect to S006. Why can't I connect to S006 when I am connected to S008? What is going wrong? What we have hit is known as the double hop problem. I can connect from my server S008 directly to S006 without any trouble at all, but I can't connect from my desktop via S008 to S006 because it is trying to do two connections, once from my desktop to S8 and then from S8 to S6. You may also experience similar errors viewing a report in reporting services that connects to SQL Server. Here you are connecting from your web browser to the web server and then onto SQL Server. Again, a double hop. So why does our query fail? Well, we're using NTLM Authentication. NTLM Authentication was the original authentication method in Windows NT. Now, NTLM uses a challenge response protocol to authenticate the user. Firstly, a user logs on to a client computer, provides a domain name, username, and password. The client PC computes a cryptographic hash of the password and then discards the actual password. And it uses this information to log into the Windows domain. The client now wants to connect to the SQL Server, so it sends the username to the SQL Server in plain text. The server generates a 16-byte random number called a challenge and sends it back to the client. The client encrypts this challenge with a hash of the user's password and returns the result to the server, and this is called the response. The SQL Server now sends to the domain controller the username, the challenge, and the response. Now the domain controller looks up the username in Active Directory and then computes its own version of the response from the password hash in Active Directory and the challenge it received from the SQL Server. The domain controller compares the response it computed in step 6 to the response computed by the client, and if they are identical, authentication is successful. But what happens when the SQL Server tries to authenticate to the second server? As we've just seen, when a client wants to use a resource, it must go through the challenge. And in this scenario, the SQL Server will try to connect to the second server using the client's credentials. So the user has authenticated to the first SQL Server. Now the first SQL Server sends the client's username to the second SQL Server. The second server generates that random 16-byte number challenge and sends it back to the SQL Server. The first SQL Server now needs to encrypt this challenge with a hash of the user's password to return it to the file server, but it can't because it doesn't know what that hash is. That is only held on the client PC, and the client PC will not pass it to anything else. so the connection fails. This is why NTLM fails. The server cannot authenticate to the next hop without the user's original password, something which it cannot get. As a result, the process can only authenticate to the next tier as itself, or null, or anonymous. Kerberos, in its ability to delegate, is the solution to this problem. Kerberos is a network authentication protocol developed by the Massachusetts Institute of Technology in the United States back in the 1980s. The name Kerberos is based on a three-headed dog figure from Greek mythology known as Cerberus, because there are three parts to the protocol. Or possibly from Harry Potter. For those of you who are Harry Potter fans, you will know that Hagrid owned a Kerberos called Fluffy that guarded the Philosopher's Stone. Now, instead of using a challenge each time a client needs to access a server, Kerberos uses a concept known as cryptographic tickets. Kerberos is faster and much more secure than NTLM, and with a threat of hacking and data theft, we should be looking to use Kerberos authentication throughout our Windows domain. With domains running Windows 2012 R2 and above, it is now possible to turn off NTLM authentication, and I would expect one day that NTLM will be dropped from Windows altogether. One major advantage of Kerberos authentication is that you can join Windows domains to other networks such as Unix, allowing you to have one password domain covering all your systems. Interestingly, prior to changes in US federal law in 2000, Kerberos was classified by the US government as a munition, i.e. a military weapon, and could not be exported outside the USA. And this is why Kerberos only became part of Windows NT with Windows 2000. There are three components to Kerberos. We have a key distribution center, which has two parts, an authentication server and a ticket granting service. And in Windows, this is the domain controller. We need a client and a server that the client wishes to connect to. The user enters his login name, password and domain, and the client passes this to the authentication server for verification. It then grants the client a TGT, or a ticket granting ticket. Think of a TGT as a general admission ticket to the domain. It allows the user permission to get onto the domain, but not necessarily access any specific service. When the client wants to connect to the SQL Server, the client uses its TGT to request a service ticket from the KDC. Now, the KDC looks up the SQL Server in Active Directory, and if the SQL Server is configured for Kerberos authentication, the ticket granting service provides the service ticket for that SQL Server to the client. Think of this service ticket as an admission ticket for a specific service within the domain. The client can now offer the TGT and the service ticket to the SQL Server. Now, the SQL Server doesn't need to contact the domain controller for verification. The fact that the client has a TGT and a service ticket for this SQL service means that it has already proven its identity to the domain controller, and that's all the server needs to know. It does not need to know the user's password. The SQL Server can now return the data to the client, assuming it has SQL permissions. One way to think of the TGT and the ST is to compare it to a visit to a theme park. The TGT gives you the general access to the theme park for that day. To go on a specific ride, you would present your TGT to the pay desk, who would then issue you with a ticket specifically for that ride, your service ticket. You would then go to the ride and present both tickets to prove that you're allowed in the park for that day and that you have paid to go on the ride. Now, when the SQL Server sees it needs to connect to the second SQL Server, it can use the client's TGT to request a service ticket from the KDC. Now, with this service ticket, the SQL Server can now connect to the second server using the client's credentials. The SQL Server can now return the data to the client, assuming, once again, you have the correct SQL permissions. As you can see, Kerberos doesn't depend on the original user password for authentication. The only time the original password is used is when the user first logs on and authenticates to the authentication server. After that point, authentication to other services is based on the user possessing a service ticket for that service. For the SQL Server to authenticate to the second server, all it needs is the client's TGT to get a service ticket. So why doesn't SQL always use Kerberos? Well, Kerberos is now the default protocol used by Active Directory. In a Windows domain, you will have logged into your PC using Kerberos Authentication. However, many services and applications don't yet support Kerberos Authentication or require extra configuration before they can use it. Every time you log in or connect to a server, it will always attempt to use Kerberos, and if it can't, it will then revert back to NTLM authentication. In many cases, SQL Server requires manual configuration to use Kerberos, so in these cases you will need to use NTLM authentication when connecting to a SQL instance. Now, how do we configure Kerberos in Windows? As I've already mentioned, Kerberos is the default protocol used by Active Directory, and your SQL Server may already be using Kerberos Authentication without you having to do anything. If not, then you'll have to configure it manually. Now, to configure a service such as SQL Server to use Kerberos, you will need to be a domain administrator, or as a minimum, have the right service principal name Active Directory permission. So the good news is that Kerberos configuration is probably not done by you, the DBA, but by a Windows or a domain admin. But in my experience, a lot of Windows admins don't understand Kerberos either. So although you won't be doing the work, it's worth understanding what's required, and even better, be able to tell your Windows admin what needs to be done. To enable Kerberos authentication on our SQL instance, we must register a service principal name, or SPN, for our SQL Server service. An SPN is a unique name by which a client can identify a service on a particular host, and these SPNs are registered into Active Directory. Now, like most complicated things that people struggle to understand, Microsoft has only produced a simple command line tool to configure it, and this tool is setspn.exe. It should already be installed on your Windows server. You can install it on your desktop as part of the Remote Server Administration Toolkit. To create an SPN, you need 4 things. You need a service class. This identifies the general class of service. For SQL Server, it is always MS SQL SVC. We need a host name. This is the fully qualified domain name in DNS of the computer that is running SQL Server. The port number, this is the port number that the service is listening on. And then finally, the service account name, the account that is running the service. So for SQL Server, it would look like what is shown on the screen. If you have aliases for your SQL Server, each of these must be registered as well, and then you need to restart SQL, and you will now be communicating with SQL using Kerberos. To complete the configuration and enable the ability to double hop, then you must make one more change, and this is to enable delegation. You can configure this using Active Directory users and computers. If you've never heard of Active Directory users and computers, this is the tool that is used to manage user and computer accounts in Active Directory. Find the service account that's running your SQL service, then select the Delegation tab, and then select Trust this user for delegation to any service, Kerberos only. If you want to be more restrictive on what this account can delegate, then use Trust this user for delegation to specified services only, and then enter the SPN details for the service you wish your SQL Server to connect to. You don't need to restart SQL when you set up delegation. Even if you aren't a Windows admin or involved in managing user accounts, Active Directory users and computers can be invaluable for checking a user's permissions in your domain. It has helped me numerous times when someone has claimed they can't get access to a SQL instance, and it turns out they aren't in the required Active Directory group. Again, Active Directory users and computers can be downloaded from Microsoft as part of the Remote Server Administration Toolkit. Now, how do we check if SQL is using Kerberos Authentication? Well, it wouldn't be SQL if there wasn't a DMV to help us. To see what authentication is being used, we need to use sysdm_exec_connections, and that is the query on the screen now. Right, let's have another demo. Let's see if we can actually get SQL to work with Kerberos. In this demo, we're going to create the SPNs that we need, enable delegation, wait a little while, restart SQL, and then rerun our SQL scripts, and let's see whether we can get them to work this time. Here I am back on my desktop of my server S008. So let me run this batch file, which is going to run the SPN-L command against my service account, and it returns nothing. So we know that there are no SPNs registered against my service account SQL Service 8. So I now have a batch file that's going to create the SPNs that we need. So let me run this one. So here you can see it's running setSPN -s MS SQL Service / the full domain name of my server, followed by the domain account that's running the service, and it's done object updated. We're then going to run it again, and this time exactly the same command, but we're going to put :1433 because that is the port number that SQL Server is running on. It's very important that you register both, one without the port number and one with. And there we have updated object. So if I hit return there, it's now going to list the SPNs again. And here we can see we have two SPNs registered against that service account SQL Service 8, which is what we want to see. Now we're just going to wait a little while. So while we're waiting, let me come down to Active Directory users and computers. Here is my service account SQL Service 8. If I double click, we have the option delegation here, and we can see that delegation is already turned on. Trust this user for delegation to any SQL service. If I wanted to, I could limit it to only only delegate to a particular service, but I'm going to leave it on for everything at the moment. So that looks fine. So everything looks correct. So the next stage is to restart SQL. So I have a batch file here to restart, so I'm going to right click and run as administrator, and that will happily stop my SQL service. Always worth just waiting a moment while Active Directory sorts itself out and SQL and everything else sorts itself out. Now let's restart the service. SQL Server has restarted. Let's come back to my desktop. Let's reconnect this connection as the SQL went down. I need to reconnect. Now let's see if my connection now works through the double hop. And there we go. We are now connecting from my desktop through SQL Server number 8 to SQL Server number 6. The double hop, the authentication and delegation is now working. And just to prove, let's list sys databases, which has that database called S006. So we know we're looking at server 6 from server 8 on my desktop. And finally, to prove it, let's run the DMV sysdm exec connections, and we will see that we are now getting Kerberos connections from my desktop Clooney 10. And the connections that are running within the server S008 actually use shared memory, so you can't have a Kerberos connection within a SQL Server. It's only connections going into it. But we can see we have two connections from Clooney 10, both using Kerberos. So that worked. Brilliant. If it's so simple, why do so many people struggle with Kerberos? Well, unfortunately, the error message you receive doesn't really tell you that you've got a Kerberos problem. The most common mistake used to be creating duplicate SPNs. It used to be very easy to create the same SPN over and over and over again. If there are two SPNs, which one is SQL going to authenticate against? Microsoft has helped here. In set SPN, originally you used the -A option to create an SPN, and this didn't check for duplicates. Microsoft added the -S option, which does check for a duplicate before it creates the SPN, and now the latest versions of set SPN, the -A option also checks, so now it's very difficult to create a duplicate SPN. You can use the -X option to look for duplicates across the whole domain. You can use the -L option to list SPNs for a particular account or computer. And then you can delete the offending SPNs with the -D option. It's also very, very easy to type it in wrong. It won't complain about spelling mistakes. Also, make sure you use the fully qualified domain name of the server when you register, rather than just the server name. If you're connecting using an alias, make sure you register that alias name as well as the server name. And you must register the correct port number as well. The SPN only works for the service account it was configured for. If you change SQL to use a different service account, you must delete the old SPN first and then create a new one. And delegation will not work if you forget to turn it on. And remember to restart SQL if you do change your SPN. Active Directory can take quite a while to replicate changes to all domain controllers, so you may have to wait a while before it works. Even when everything seems to look correct, it can still not work. The ticket on your PC may not recognize the new SPN. klist.exe, which is part of the Remote Server Administration Toolkit, allows you to list cached tickets on your desktop and purge them, forcing your PC to obtain a new Kerberos ticket. In Active Directory users and computers, there is a setting called Account is Sensitive and cannot be delegated. And if this is set, then your account won't be allowed to do the 2 hops. Kerberos is time sensitive. If the time is not correct across all servers in the domain, then Kerberos may fail. If the TC port or IP address changes, then the SPN will have to be deleted and recreated each time. If you're using a SQL named instance, then change the dynamic port to a fixed port to avoid this issue. And ensure that your SQL Server has a fixed IP address rather than using DHCP. Make sure that the server at the end of the hop is also configured for Kerberos. And if you're using a hosts file, ensure that the server name has the fully qualified domain name. Better still, do not use the hosts file. And sometimes you just have to be patient and wait for the changes to take effect. Now you may remember I said that there's only a command line tool for managing SPNs. Well, Microsoft have developed a graphical tool especially for SQL Server called the Microsoft Kerberos Configuration Manager for SQL Server, and it is really, really, really good. This will tell you what SPNs are missing or duplicated from your SQL instance, and it will even write the SPN scripts for you to give to your Windows admin. And this is a must for any SQL DBA dealing with Kerberos. The latest version is version 4.1, supports SQL Server 2017, and will also provide SPNs not just for your databases but for your SSRS and SSAS. Previous versions, version 3 and version 2, didn't provide all that functionality, but if you are still using older versions of SQL, then they tend to work better with those versions than the newer one. I do have copies of versions 2, 3 and 4 if you're struggling to get hold of the older versions. But if you are a DBA, I highly recommend you get hold of the Kerberos Configuration Manager for SQL Server. Other tools that you can use, DBA tools. This is a huge suite of PowerShell scripts written by the SQL community. I highly recommend you take a look at them. There is commands available that can help with your Kerberos configuration. ADC-Edit, DS-ACLs and KList are part of the Remote Server Administration Toolkit and can be helpful in resolving Kerberos issues. You may be wondering why we have to go through the pain of creating SPNs manually. Why can't SQL just create them automatically? Well, SQL Server can, and it does. By default, when the SQL service starts, it will attempt to register the SPN, and you will see in the error log a message showing SQL Server trying to register the SPN. If your service account has permissions to create the SPN, the right service principal name permission, then it will automatically create an SPN when SQL starts and automatically delete it when it shuts down. But if your domain account doesn't have permission to create SPNs, which is usually the case, then we have to create the SPNs manually. If you're using SQL 2012 and above, then it's quite likely you're using a virtual account, also called a local managed service account for your SQL Server service. For SQL Server, this is called ntservice/ms SQL Server, and this account is managed by the local server. You do not need to know the password. Now, because a managed service account is a local account, so it's part of the operating system, it can register an SPN itself automatically, which means that your SQL Server will be using Kerberos by default. When you use a locally managed service account, the SPN is registered against the server name. So when configuring delegation, you must configure it against the server. There is no domain user account to configure it against. A much better choice for your service account is something called a group managed service account. And this is a user and a computer at the same time. Unlike the previous local virtual account, these are held in Active Directory and the passwords are generated and maintained by the key distribution service. Group managed service accounts cannot be locked out, cannot perform interactive logins because no one knows the password. Active Directory automatically can update the group managed account with a new password without having to restart anything. There's two types. Managed service account is assigned to a single computer and it requires Active Directory functional level 2008 R2 and SQL 2012 and above. And we have group managed service accounts, which is a managed service account for multiple servers. It requires Active Directory functional level server 2012 R2 and is supported by SQL 2014 and above. This is the choice that you should be using if you're doing failover cluster instances and availability groups, where you need to have the service account the same on all nodes of your cluster or your availability group. Setting up group manager service account is not straightforward. It does take quite a long time. It's definitely something for your domain admins to be doing, but once built, once configured, they do work. They automatically create your SPNs for you. They're secure because no one knows the password, and they're managed by Active Directory, so they are definitely the option that you should be using going forward with all your new SQL servers. If you want to read more about group managed service accounts, there's a very good article on MS SQL Tips by John Martin. I definitely recommend you give that a read to learn a bit more about group managed service accounts. Time for one final demo. Here I am back on my server S008 and I have loaded up Kerberos Configuration Manager. I can now go connect, type in the name of my server that I want to look at, so CLW-SW-S006 in this case. Click connect. Give it a moment to go and connect to the SQL Server and download the information. And we've now retrieved all the information about my server S006. So if I click on SPN, it will now show us the information about our SPNs, or what should be on there. So on this particular server I've got two instances running, one 2014 and one 2017. Gives us the port numbers, tells us the service accounts that we're using, the required SPN that we require for those instances, and whether they're missing or not. So the server 2017, which is the one that we were using for the end of our double hop, has got SPNs running, but my 2014 server is missing them, so I could click on generate and actually generate a batch file which will have the correct set SPN command for me. Or if I was a domain administrator with the necessary permissions to actually create SPNs, I could click on fix and it would automatically create the SPNs required for me. We also have this tab here, Delegation, so we can see here for my 2017 instance there are no delegation issues, but for my SQL 2014 issues it is not configured for delegation. So Kerberos Configuration Manager can be a very handy tool. It can be a bit flaky at times, but it is definitely worth downloading and giving it a go if you're a DBA and you need to check your SPNs. Finally, let me load up PowerShell. So here I have a PowerShell window. I have loaded up the PowerShell DBA tools from dbatools.io, and these are the commands that are available to you. So we can run get DBA SPN, specify an account name. So in this case, this is the service account that we are using on my server, and we can see here it's found the SPNs that are configured for that service account. We can also list the SPNs for a particular computer. So if I go to S006 again, this will now go and interrogate that Windows server and return some information. So here we can see S006. We have two SPNs currently configured, as we know, for the SQL 2017 instance. We can also test for SPNs. So again, if I run this on S006, give it a moment to interrogate the server. And here we have all the information about the SPNs on our server. So for this particular line, which is for our 2014 instance, you can see that it thinks the SPN is missing. It actually gives us the SPN that we need and the service account. Similarly for this one, again, this is for this one it's for the 27 instance, so it's quite happy and sees that the SPN has been set, and it does that again. For the 2014, SPN is missing, and again for the 2017, SPN is set. So that's quite a useful set of information. Once you've got the information you need for your SPN and your account, you can then use the set DBA SPN command to actually create the SPN for you. And then if you ever need to remove it, you can use the remove DBA SPN command as well. So I highly recommend that you take a look at DBA tools, not just for managing your SPNs, but all aspects of managing your SQL Server instance. They are a very comprehensive set of commands which are continually being added to and growing. DBA tools along with the Kerberos Configuration Manager are definitely two tools that you should be considering using if you need to interrogate or set any of your SPNs. Well, that brings us to the end of this talk. Hopefully you now have a better understanding of Kerberos and you'll be able to use it safely and securely in your environment. I have many more videos on SQL Server on my YouTube channel. Please go and have a look. If you have found this video useful, please leave a comment for me, and I hope to hear from you soon. Thank you very much.